My name is Matías Londoño, study at UPP College, intersemester, and today I'm going to talk about Hoogen-Kinchy tables attenuates the endoplasmatic reticulum stress in non-alcoholic fatty liver disease rats by regulating PERK and ATF6 pathways. In the introduction, I'm going to talk about general concepts of the article. First, a non-alcoholic fatty liver disease that is defined as the accumulation of lipids in the hepatocyte cytoplasm and formation of lipid droplets in the hepatic tissue. Another definition that is important is that Hoogen-Kinchy tables that are a traditional China medicine that are composed by different plants, are like five different types, and the main components are the flavonoids, glycosides, alkaloids, saponins, and organic acids. In this image we can see the two ways that are the more important to regulate the endoplasmatic reticulum stress, that are the PERK and ATF6 pathway that are induced by the endoplasmatic reticulum stress, and we can see how the Hoogen-Kinchy tables can inhibit that two pathways and can ameliorate the steatosis inflammation. The general objective was to know the underlying mechanism of the Hoogen-Kinchy tables in the regulation of non-alcoholic fatty liver disease and the effects. Los métodos que utilizamos fue el método ELISA, que se utiliza la unión de un antígeno con un anticuerpo para conocer la presencia si hay una presencia de ciertas proteínas. En este caso lo utilizamos para conocer la presencia de la interleuquina 1 beta, interleuquina 6, factor de necrosis tumoral. También utilizamos Western blot, que es para separar y conocer la presencia de ciertas proteínas. Esto se hace por medio de electroforesis, y entonces por cargas eléctricas separa las proteínas, y esto me da unas bandas en donde puedo mirar la expresión de cada proteína y, por así decirlo, la cantidad que hay. También utilizamos PCR en tiempo real, que se utiliza una secuencia específica de ARN mensajero y la transcribo a ADN y cuantifico cuánto se transcribió. Esto se hace en tiempo real. La examinación histológica es utilizar un corte específico de un tejido y lo tiño con ciertos colorantes, así evalúo características no solo del tejido sino también de las células que lo componen. En este caso utilizamos dos colorantes, que fueron la hematoxilina eosina y el oil red O, que fue para evaluar la infiltración de lípidos dentro del parénquima hepático. In the results, we can see that in the control group, the hepatocytes are neatly arranged and there's no signs of inflammation or cell infiltration. In the high fat diet group, we can see the inflammation, signs of cell infiltration, and formation of lipid droplets. In the other groups, like the low doses group, the high dosage group, and moderated dosage group, we can see that the Hoogen-Kinchy tables alleviate the inflammation and the accumulation of lipids into the hepatic tissue. In the oil red O staining, we can see the accumulation in the high fat diet group, and we can see too that the Hoogen-Kinchy tables alleviate the accumulation of lipids into the hepatic tissue. In the figure 7, we can see some endoplasmatic reticulum markers, stress markers, like the GRP78, that shows that is upregulated in the high-fat diet group and downregulated in the other groups. That same pattern is repetitive in the other proteins and signaling pathways. In the figure 8, we can see how the ATF6 protein are upregulated again in the high-fat diet group that are not treated with the Hoogen-Kinchy tables, and downregulated in the other groups. That same pattern is like the common thing in the other proteins. the discussion, we can see that Chang in 2015 says that Hugan-Kinshi table has been identified as potential modulator of non-alcoholic fatty liver disease through its lipid lowering and anti-inflammatory effects. That's true because we proved that the Hugan-Kinshi tables have anti-inflammatory effects. Xiaoji 2020 says that recent studies demonstrated that endoplasmatic reticulum stress plays an important role in the development of non-alcoholic fatty liver disease. That's true because when we inhibit the signaling ways that are the endoplasmatic reticulum when in stress, we can see this diminution of non-alcoholic fatty liver disease symptoms and signs. Lister K at 2018 says that meanwhile high cholesterol and high TG levels in non-alcoholic fatty liver disease can induce endoplasmatic reticulum stress, which further exacerbates cholesterol accumulation and ultimately leads to a vicious cycle of non-alcoholic fatty liver disease development. That's true because the accumulation of lipids in the cytoplasm of the hepatocytes and formation of lipid droplets can induce a non-alcoholic fatty liver disease. Finally, we can say that the techniques that used in molecular biology help to identify specific signaling pathways, and that's crucial to development of target investigation and the treatment of pathologies. And finally, these kind of studies are designed for the necessities of the population because they talk about the importance of the lifestyles and the importance of the alimentation, and that show us the investigators interested to the general population health.